Human in the Loop is built around a simple question. If AI can perform a task, should it perform that task on its own, or does a human need to be involved somewhere in the process? Because as AI systems get more powerful and AI agents can run for like hours at a time autonomously, we have to decide how much we humans are willing to let the AI work unsupervised. So broadly, human in the loop is the idea that humans should be embedded somewhere in an AI system's workflow. And human in the loop is actually a spectrum of human involvement. So on one end, you've got human in the loop itself, kind of strict HITL. This is where the system literally stops and waits for a person to approve before it proceeds. So the AI makes a recommendation, or maybe it performs some kind of subtask, but then a person is going to need to make the final action, give the go command, say, hey, let's do it. Now in the middle, you've got something called human on the loop. This is where the AI operates autonomously, but a human monitors the process and has veto power to hit the kill switch or override the system if things go pear-shaped. And then on the far side of the spectrum, you have got human out of the loop, which is full autonomy with no human involved at all. So the AI senses, decides, and acts. It's doing all of that without any human intervention. And in some cases, the system operates at speeds where human intervention wouldn't be possible anyway. So some quick examples of this. So for human in the loop, let's consider an example would be medical AI. So this is medical AI that flags, let's say, potential tumors on an X-ray, but requires a radiologist to make the final diagnosis. This is a high stakes environment where the cost of a false positive or false negative is extremely high. For human on the loop, well, given that I drove my car to the studio today on FSD, I'm going to say that supervised self-driving is a good example of that. So that is where the car is doing all of the work of steering and maintaining speed, but the driver, me, is still required to keep my eyes on the road to make sure that I can take over if I need to. I still have to pay attention rather than using my time to do something better, like watching Jeff Kroom YouTube videos on the drive-in. And then for human out of the loop, a good example of that is something that happens very fast. So for example, high frequency trading is a good example of that, because these algorithms, they operate at such speed and scale that humans cannot physically react before thousands of trades have already been executed and the market's moved on. So we need to decide whether we need a human in the loop, and if we do, where in the process should we put them? Because there are really three places you can inject human involvement into an AI system. Those three places are at training time, at tuning time, and also at inference time. And each one of these, it solves a different problem. So let's start with training. Now, before a model can learn anything, somebody has to label the data it learns from. That's a pretty well-known technique in machine learning, and it's called supervised learning. This is humans looking at thousands of examples and then tagging them. So for example, looking at an email and saying, yes, I think this email is spam. Or maybe it is looking at an image. So perhaps it looks at this image here and it says, this image is a stop sign. Now, without those human provided labels, the model has no ground truth to learn from. But labeling data like this, it's expensive, it's slow, it's pretty boring for humans, and for specialized domains like medical imaging or legal document review, you're going to need an expert to do it. So what if instead of labeling everything, you could label just the stuff that matters most? And the process for doing that is called active learning. Now, in active learning, the model trains on a small labeled data set like this, and then it looks at all of the unlabeled data that we haven't got to yet. So here's my data set with some unlabeled data in it. And then it says, well, I'm pretty confident about, let's say, these examples here, but these other ones here, I'm kind of 50-50 on. I'm not sure what these things are. I need a human to tell me. So the human effort is concentrated on the really hard cases that the model cannot reliably perform itself. Now, let's move on to tuning. So for example, let's talk about if we want to tune a large language model, and we want to tune it to respond in ways that are helpful and harmless and honest. Now, just a raw pre-trained LLM can predict text, but it really has no concept of what a good response looks like. And you can't really write a formula that says, hey, LLM, I want you to be like helpful, but if you could dial back the creepiness factor, that would be nice. So what do you do when you can't really write a rule for something like that? Well, you get the human to show it. And that is a technique that is called RLHF, reinforcement learning from human feedback. So in RLHF, a model generates two responses. Let's call them A and B for every prompt. And a human looks at both and it says, I think option A is better this time. So the human isn't labeling anything, or they're not correcting anything. They're specifying a preference. And RLHF collects thousands of these preference pairs, and it uses them to train something called a reward model. And a reward model is a completely separate model that learns to predict which option humans would prefer. And then the reward model is used to coach the original LLM through reinforcement learning. So the human's judgment is effectively getting incorporated into the system without needing a human there at runtime. And speaking of runtime, the third place you can put human in the loop is at inference time, the live system in production. And this especially applies to agentic AI, because agents, they do more than generate stuff like text and images. Agents take actions, they execute code, they modify databases. So here are a few common patterns for this. One of them is confidence thresholds. The model scores its own certainty on every prediction, and if that prediction drops below a set threshold, then it routes that to a human. So the AI handles the easy 90% and the humans handle the uncertain 10%. Then there are approval gates. So the AI proposes an action and a human has to explicitly approve it before the system proceeds. And well, that's how many coding agents work today before doing something like making a change to a file system. And then escalation queues. The AI handles routine cases end to end, but it flags edge cases for human review. So training time, tuning time, inference time. What has human in the loop done here? Well, labeling has given the model knowledge. Our preference tuning here, that has given the model judgment. And runtime oversight, that has given the model guardrails. Now, human in the loop isn't without its trade-offs. So let's talk about a couple. One is scalability. Every human touch point is a human-shaped bottleneck. So if a system processes thousands of decisions per second, the humans are going to need to be a bit strategic about where they insert themselves. And there is also consistency. Two people will label the same data differently because humans. Fatigue, bias, subjectivity, these are very human traits. But the goal of human in the loop was never to keep humans in the loop forever. It's to keep them there until the system earns enough trust to move along that spectrum we talked about, from human in the loop to human on the loop to human out of the loop entirely in some cases. That's the maturity curve of every AI deployment. Even the most autonomous systems we have today, they started with human in the loop somewhere. The human taught it, the human tuned it, the human monitored it until it was ready to go alone, which means maybe one day I really will be able to watch Jeff Kroom lightboard videos on my drive to the studio.